Hey guys, tonight we slip into the very first spark of existence itself. Imagine total darkness, except it isn't even darkness, it's less than that. No stars, no planets, no space to put them in. Then, without warning, everything detonates in a single, unfathomable instant, the Big Bang. You don't hear it because sound requires air, and you don't see it in the way fireworks explode across a summer night sky. Instead, you feel it. If feel could stretch to describe a flood of energy so blistering that even atoms can't survive. Temperatures climb above 1 trillion degrees, hotter than the core of any star that will ever exist. And you, poor fragile human, are technically here in this retelling, though you probably won't survive this particular stroll through cosmic history without vaporizing before the first femtosecond passes. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, let me know in the comments where you're listening from and what time it is for you right now. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge forward, metaphorically at least, through the blinding haze of the newborn cosmos. In the first flicker of a second, the universe balloons outward faster than light itself, an expansion so wild that calling it explosion doesn't quite cut it. Inflation, scientists later name it, stretching space-time like taffy until quantum ripples are blown up into vast patterns. This inflationary phase is short, unimaginably brief, yet it seeds the structure of everything to come. Without it, galaxies would have no foundation to cling to, and stars might never ignite. The obvious truth here is simple. Without inflation, the universe as we know it wouldn't exist at all. As you float inside this furnace, it's hard not to think of it like standing inside a nuclear reactor that fills all of reality. Particles swarm, quarks, gluons, electrons, smashing into one another in a frenzy. They don't form anything stable yet. No protons, no neutrons, no comforting little building blocks of matter. For a fleeting moment, it's just pure plasma soup, the recipe of everything. Though you wouldn't want to taste unless you enjoy temperatures that melt steel 1 billion times over. And yet, fringe theories crop up, whispered on the edges of physics conferences, suggesting this soup wasn't the only one. Some argue multiple bangs may have rippled into existence, each universe inflating like a bubble in some incomprehensible froth. Historians still argue whether this idea of a multiverse belongs more to physics or to philosophy. Your senses adjust, in a dreamy way, as the seconds tick by. Not that seconds mean much when time itself is just learning to walk. By the first minute, protons and neutrons emerge, clumping like exhausted marathoners huddling together. Hydrogen and helium nuclei form in nuclear forges that make even the sun look like a candle. You stand in awe, watching the very stuff that will someday breathe life into stars, planets, oceans, and you. A quirky tidbit floats into your mind. This exact recipe, 3 parts hydrogen to 1 part helium, with traces of lithium, is so specific that it remains nearly unchanged today, billions of years later, still written into every star you see twinkling above your head. You drift deeper into this timeline, the afterglow of creation still pressing against your skin like heat from an oven door. The radiation is everywhere, filling every corner of space, bouncing off nothing, trapped in a fog of particles too dense for light to escape. The photons here are restless prisoners, colliding endlessly, never free to stretch their legs. It's claustrophobic, like being stuck in a concert mosh pit where every time you try to move, someone shoves you back into the crowd. And yet, those photons, those stubborn little messengers, will someday carry the earliest story of the cosmos to our modern eyes. As the first few minutes lengthen into hours, then into thousands of years, you notice the universe steadily cooling. It's like an oven finally shut off, still radiating heat, but slowly settling down. By the time it drops below 3000 Kelvin, the fog will thin enough for light to break free. That moment, still far ahead in your journey, is when the cosmic background radiation finally slips loose, a faint but eternal echo of this fiery nursery. But don't rush there yet. Stay in this searing instant a while longer. Imagine your hands stretching out, though they'd be obliterated, to scoop up glowing plasma. Imagine listening for sound, though what you'd hear would be more like deafening ripples of pressure waves vibrating through primordial fire. Even here, the seeds of galaxies are vibrating, tiny quantum jitters written into the fabric of reality. Later, they'll blossom into Milky Ways and Andromedas, but right now they're just faint ripples in a storm too bright to see. It's oddly comforting, in a way, that all the beauty of night skies, all the comets, nebulas, and exoplanets yet to be discovered, were once packed inside this first hot breath. You're floating inside both chaos and promise, inside destruction and creation at once. And even if you don't survive the searing winds of the Big Bang itself, at least you know you're part of a story that began right here, in this blinding flash that still whispers across the universe today. You linger as the firestorm that began everything keeps stretching outward, your perspective drifting with it like a speck of ash caught in a gale. The expansion doesn't slow, it races on, ballooning reality itself, and with every fraction of a second, the fabric of space dilates further. You can almost hear it groaning, not like wood bending, but like something stranger, space-time stretching without tearing. And though you feel small, you also feel connected, carried in the very breath of the universe. Photons, those jittery messengers of light, are all around you, but they're trapped in a kind of cosmic traffic jam. Imagine standing in a fog so thick you can't see your hand in front of your face. Now imagine that fog is glowing with unbearable heat. Every photon bounces endlessly off electrons, ping-ponging back and forth, never allowed to travel freely. The universe at this moment is opaque, a glowing fog bank, and no matter where you turn, you're blinded. The obvious truth here is simple. In its infancy, the universe was not dark, but overwhelmingly bright, so bright you'd have no chance of seeing through it. Yet something enchanting is happening beneath this blinding glare. With every passing 1,000 years, the furnace cools just enough for particles to settle into something more stable. Protons and neutrons, those once frenzied dancers, begin to relax into hydrogen and helium atoms. For the first time, there is stability in matter, a shift from chaos into structure. You drift past regions where clouds of this new atomic gas float, glowing faintly, waiting for gravity to tug them into the first stars. Scientists still argue whether this transition should be thought of as a gentle settling or a dramatic phase change, like water freezing into ice. Either way, it's the pivotal step, the moment when the universe begins to make sense, when physics writes down the first clear laws in the form of stable atoms. Without this shift, no galaxies would coalesce, no stars would ignite, and you wouldn't be here to wonder if the microwave oven in your kitchen is whispering secrets from this very fog. And that's the quirky part. Billions of years later, this same glow, stretched and thinned by the expansion of the cosmos, would become so faint it hides in plain sight. Every time you heat up leftovers, your microwave is tuned to the same frequency as the ancient radiation humming across the universe. The irony is delicious. Your pizza rolls are cousins to the oldest photons ever released. As you hover in this infant cosmos, the heat gradually eases from intolerable to merely devastating. Think of it as walking away from a campfire. Though in this case, the campfire was the birth of everything, and walking away takes hundreds of thousands of years. Slowly, the universe becomes less like molten glass and more like a simmering soup. Temperature falls, pressure relaxes, and for the first time, photons begin to rattle with the possibility of freedom. They're still chained to electrons, still colliding, but their restlessness grows. You sense it like the way a caged animal paces, waiting for the door to creak open. Some theorists even whisper about phantom traces in this moment. Primordial magnetic fields, subtle alignments in the plasma that might have left fingerprints we can still search for. Whether they were really there remains one of those tantalizing unknowns. Scientists debate with the zeal of detectives poring over half-burned evidence. Did the earliest seconds forge faint magnetic imprints that seeded galaxies? Or are we chasing ghosts born from wishful thinking? No clear verdict yet, just the hum of scholarly voices drifting on like background static. You float deeper, through millions of years that slip past in a dreamlike rush. The fog around you grows thinner, cooler, quieter. Photons still knock into electrons, but less violently, less often. Every encounter feels like a slowed-down game of bumper cars. You can almost imagine them whispering apologies before ricocheting off one another. Gradually, this vast ocean of light and matter learns a kind of uneasy balance. The sensory detail is overwhelming. The heat is still oppressive, but not blinding. The plasma glow flickers, shimmering with hints of transparency just beginning to form. If you reach out your hand, you'd see nothing, yet you'd feel waves of radiation brushing against your skin like invisible surf. You imagine, just for humor's sake, if sunglasses could survive here, you'd need a pair darker than anything Oakley ever dreamed of. Even then, good luck trying to look cool in a universe still hotter than the surface of the sun. But the narrative of this cosmic fog is not only one of heat, it's also one of patience. Every photon, every atom, every ripple of plasma is waiting for a single threshold, the moment when the fog finally clears. That future moment will become the cosmic background radiation, the light that escapes and never stops traveling. For now, though, you're stuck in a universe where light is imprisoned, trapped in a haze that makes even the thickest London fog look like clear summer air. And still, within this imprisonment lies hope. The seeds of everything, the faint density ripples, are embedded in the plasma like fingerprints in wet clay. You can't see them now, but you will someday. Etched across the sky in subtle variations of temperature and color, the universe's earliest baby photos waiting to be developed. As you drift in this glow, you realize the strangeness of your situation. You're inside a cosmos both impossibly violent and serenely calm. It's as if you're watching a bonfire from the middle of a quiet dream. The violence is undeniable, yet so too is the beauty. And somewhere, just beyond your reach, the first clear light of the universe is waiting to break free, carrying with it the memory of everything you've just witnessed. The fog around you grows thicker, almost like a living thing pressing in on all sides, glowing with a fierce orange haze that burns into your mind even though your dreamlike self can somehow withstand it. You're standing inside a cosmos that, for all its energy, is blind to itself. Light tries to move, but it can't get far. Every photon slams into electrons the way a pinball rattles inside a machine, ricocheting endlessly. The truth here is blunt. The early universe was opaque, utterly incapable of transparency, a blinding soup where sight was meaningless. But the fog doesn't last forever. The universe is stretching, cooling, loosening its grip on light. Imagine a sauna cranked so high that you're about to faint, then slowly dialed down until you can breathe again. That's what's happening now, on a cosmic scale. Atoms are finally forming in earnest, electrons slipping into orbit around nuclei, instead of careening wildly. The moment is called recombination. Though, let's be real, the name is misleading, since nothing had really combined before. Still, it marks the dawn of clarity. With electrons bound, photons are no longer constantly blocked. The fog begins to thin. It's tempting to compare this transition to morning mist burning off under sunlight. But here, the mist itself is light, and what's clearing is the prison of matter that once held it captive. You watch as photons stretch their wings, eager to travel freely across space for the first time. Those very photons, if you could ride one, will continue journeying for billions of years, eventually washing into your eyes today as the faint microwave glow that fills every corner of the night sky. The quirky tidbit is this. If you were to build a television with no signal, the static fuzz between channels is partly sprinkled with those ancient photons, the first light of the cosmos smuggled into your living room. You drift further, marveling at how sudden yet gradual this shift feels. The plasma fog that once blinded the universe begins to part, and transparency spreads like a tide rolling outward. The phrase surface of last scattering comes to mind, a poetic bit of jargon scientists use. It's the final time photons collide with matter before streaming outward forever. You hover at this surface, though calling it a surface is like calling an ocean wave a solid wall. Still, there's romance in the idea that the universe has just taken its first visible snapshot, its baby picture written in light. And yet, mysteries hide within this fog's dispersal. Historians still argue whether the process was entirely smooth or if strange anomalies lurked in the plasma. Some whisper about early dark energy, a fleeting force that may have nudged the timing of recombination, tweaking the picture we see today. Others counter that our instruments, not the cosmos, are to blame for oddities. The debate is as murky as the fog itself, never quite clearing no matter how many data points we gather. Sensory detail presses on you. The heat has dropped to around 3,000 Kelvin, still hotter than molten lava, but finally survivable in the abstract way of this dream journey. The glow is no longer an unbearable blaze, but a reddish warmth, like embers after a massive fire. The fog has texture now, softer, almost velvet-like, and you could almost imagine brushing it aside with your hand. In fact, in your more playful moods, you wonder if the fog is a cosmic curtain being pulled open to reveal the stage where galaxies will perform. Cue the orchestra. A gentle sarcasm bubbles up as you picture the universe practicing its stagecraft. Ladies and gentlemen, we proudly present everything. It's both absurd and profound, and you grin at the thought. Humor helps when you're wandering in a place where time is measured not in hours or days, but in tens of thousands of years. As recombination marches on, atoms settle comfortably, and photons finally slip into open space. The first clear light has arrived, not as a blaze of fireworks, but as a calm, all-encompassing glow. There are no shadows, no beams, no lamps, just a soft bath of radiation everywhere at once. It's oddly comforting, like being wrapped in a blanket woven from pure starlight. You want to curl up and drift to sleep in it, even though you know that light is too hot, too raw, too ancient to soothe anyone in real life. Still, in this dreamlike journey, you allow yourself to float inside it, cocooned in warmth. And in that warmth, you notice patterns. Tiny ripples of density, frozen into the plasma before recombination, now translate into faint variations in the glow. They're subtle, barely perceptible, but they will someday become crucial clues. Those ripples are the fingerprints of inflation, of the jittery quantum foam that once ruled the subatomic. Without them, everything would be smooth, and a smooth universe is a boring one. No stars, no galaxies, just a bland haze stretching forever. Thankfully, the cosmos enjoys a little texture. You linger here at the threshold, this liminal space where light finally claims its freedom. Behind you lies the fog, dense and blinding. Ahead stretches openness, clarity, and the promise of a visible universe. And even though you know the photons are racing far beyond you, you feel oddly content standing at this cosmic curtain call, watching as the first chapter of visible history begins to unfurl. You drift onward, carried by the now-freed photons as though you've hopped on the universe's oldest shuttle service. They spill out in every direction, stretching into the vastness, filling space like an ocean that has no shore. The blaze of the Big Bang has softened into something more subdued, still radiant, still hot, but now faint enough that it will eventually trickle down into a signal we can catch billions of years later. You realize, with a wry smile, that you're floating inside the light that will someday make your microwave oven hiss with static. The obvious truth here: the cosmic background radiation is everywhere, utterly unavoidable, a faint but eternal bath of energy that permeates the whole sky. Your mind drifts to the strangeness of it. Those photons, set free nearly 380,000 years after the Big Bang, have been traveling ever since, stretched and cooled by the expanding universe. They've shifted from a fiery glow into microwaves, invisible to your eyes but detectable by antennas. And that's the quirky detail. If you had an old-school analog TV and turned the dial to a dead channel, a tiny fraction of the static fuzz was this very radiation. Who knew that between sitcom reruns and commercials, the cosmos itself was sneaking in a cameo? You glance around in this dreamlike landscape, and instead of emptiness, you're surrounded by a glow that has no direction. It's not coming from a lamp, not shining from a star, but rather filling every corner equally. It's uncanny, like sitting inside a softly lit dome with no source. The sensory experience is odd, warm, even comforting, though you know the actual temperature of this background light today has cooled to just 2.7 Kelvin. That's only a whisper above absolute zero, colder than any freezer, colder than Antarctica's night. And yet here, in your drifting journey, it feels like an ancient quilt wrapped tightly around you. Scientists, of course, didn't stumble on this glow right away. For most of history, nobody had a clue it existed. Aristotle didn't pin essays on it. Galileo didn't aim his telescope to capture it. And even Newton's prisms couldn't bend it into view. The radiation was too faint, too stretched, invisible to human senses. It took modern detectors, horn-shaped antennas built in the mid-20th century, to stumble across it. And when they did, the story involved a pair of scientists, a whole lot of confusion, and, of all things, pigeon poop. But that tale will come in its own moment. For now, you keep gliding through this faint glow, marveling at how it acts like a time capsule. Each photon is a messenger, carrying with it a story from the moment of last scattering. Together, they form a photograph, not in glossy paper, but in faint microwaves, that reveals what the universe looked like in its infancy. The debate, of course, is how perfect that photo really is. Historians still argue whether anomalies in the cosmic background are genuine imprints of something exotic, like early dark energy or even neighboring universes, or whether they're just smudges from our instruments. The jury is still out, but the glow keeps whispering its secrets regardless of how humans squabble. The glow itself hums around you, almost like background music. You imagine tuning a cosmic radio, the dial picking up a hiss that's been playing since the dawn of time. If this were a sleep soundtrack, it would be the ultimate ASMR, a steady, gentle static born from the universe's very first breath. You chuckle at the thought. If Spotify ever released Big Bang noise, lo-fi cosmic static, you'd probably loop it all night. Yet beneath the humor, you sense the grandeur. These photons aren't random, they're structured, patterned. The faint variations in their temperature, just millionths of a degree, outline the scaffolding on which galaxies will form. You could think of it as a cosmic connect-the-dots game, where the dots are cooler and hotter patches in the sky. Someday, those patches will translate into sprawling galaxy clusters and vast voids. But right now, they're just ripples on a soft microwave glow. You stretch out your arms, half expecting to feel something tangible in this radiation. But of course, there's nothing to touch. It's light, after all, not air or liquid. And yet you swear the glow has a weight, a presence pressing gently on your skin. You imagine wrapping it up in a jar, taking it home, and labeling it vintage light, circa 13.8 billion years. Then you laugh. Someone would definitely list that on eBay. Still, what comforts you most is the universality of it. No matter where you go, Earth, Mars, or some far-flung exoplanet orbiting another star, this radiation will follow. It doesn't care about borders, politics, or who's in charge of the latest space agency budget. It is simply everywhere, humming quietly in the background, a reminder that everything shares the same beginning. And as you drift inside it, you feel less like a lone traveler and more like part of an endless, shared story, written in light older than any star. You drift forward, still wrapped in that gentle microwave glow, and your perspective fast-forwards a few billion years. The scene shifts not to a fiery plasma haze, but to a quiet field in New Jersey in the 1960s. Two radio engineers, Arno Penzias and Robert Wilson, are wrestling with a problem. They've built a giant horn antenna to study signals bouncing off satellites, and no matter what they do, their receiver keeps picking up an annoying hiss. It's steady, it's everywhere, and it refuses to leave. The obvious truth here: sometimes the universe delivers its secrets not to astronomers staring through telescopes, but to engineers just trying to do their job. You stand beside them as they scratch their heads, adjusting dials, checking cables, blaming the weather, blaming the equipment, and then blaming pigeons. A pair of birds has taken up residence in the horn, leaving behind what the official papers delicately call a white dielectric material. In other words, pigeon poop. Wilson and Penzias climb inside, evict the birds, scrub down the antenna, even don rubber gloves for a job that's decidedly less glamorous than cosmic discovery. But when they switch the system back on, the hiss is still there, stubborn and unyielding. The quirky tidbit: the very glow of the Big Bang was mistaken for bird droppings before anyone realized what it was. You can almost hear them sighing in frustration, unaware they're on the verge of a Nobel Prize. Meanwhile, across town, a group of Princeton physicists has been working on the idea of cosmic background radiation, predicting exactly this kind of faint signal. The two groups collide, one with theory, the other with noise, and suddenly the hiss isn't a nuisance, but a revelation. The universe has been whispering all along. It just needed the right pair of ears to listen. Historians still argue whether Penzias and Wilson fully grasped the magnitude of their discovery in the beginning, or whether it took years of hindsight and accolades to sink in. Some accounts paint them as bewildered engineers swept along by theorists. Others suggest they quickly realized they'd stumbled on the smoking gun of cosmology. Either way, their static became a cosmic anthem, confirming the Big Bang model and silencing, for the most part, rival theories that the universe had always existed in a steady state. The sensory details of that moment are humble compared to cosmic explosions. There's no blinding light, no roaring plasma, just two men standing in a field, their ears filled with the faint hiss of an antenna, birds fluttering nearby. You imagine the cool New Jersey air, the smell of scrubbed metal, and the quiet hum of electronics. In this everyday setting, the echo of creation itself was decoded. It's a bit like finding the Holy Grail at the bottom of your kitchen sink. You let the scene wash over you, marveling at how human clumsiness and curiosity intertwine. The Big Bang's proof didn't arrive in a flash of divine inspiration. It arrived in the form of stubborn background noise. If this were a comedy sketch, you'd imagine one scientist saying, "It's either pigeon poop or the birth of the universe," and the other replying, let's publish just in case." But beyond the humor lies something profound. The discovery of the cosmic microwave background provided the universe with its first clear baby photo. The glow mapped across the sky confirmed that the cosmos had indeed exploded into being, expanding and cooling exactly as the Big Bang theory predicted. From that faint hiss, an entire new chapter of cosmology unfolded, guiding satellites like COBE, WMAP, and Planck decades later. As you step back from the horn antenna, the noise takes on a different quality. It no longer sounds like interference. It's a lullaby, steady and soft, humming from the beginning of time. You close your eyes and realize that every person alive, every city buzzing, every star gleaming, all of it exists under this same blanket of faint radiation. The hiss is the universe's way of saying, "I was born, and I have not forgotten." The hiss that Penzias and Wilson stumbled over refuses to stay just noise in your mind. You follow it, letting the static expand into an entire canvas. As you drift across this invisible glow, you begin to notice faint speckles, tiny variations, cooler here, slightly warmer there, differences of only a few millionths of a degree. To the naked eye, they'd be invisible. But mapped out, they form a patchwork across the sky, like delicate brushstrokes on the universe's first painting. The obvious truth: the cosmos is not perfectly smooth, and that imperfection is exactly what allowed galaxies, stars, and you to exist. The variations are tiny ripples frozen into light itself, temperature fluctuations left behind by pressure waves in the primordial plasma. Imagine a cosmic drum, vibrating before light escaped, its beat captured forever in the glow. These ripples are subtle, so subtle that when satellites first revealed them, scientists wept at the beauty of it. Without those slight density differences, gravity would never have had the foothold to pull matter together. No ripples, no clumps. No clumps, no stars. And without stars, well, you'd be sitting in a pitch-black nothing, wishing you'd brought a book to read. Except even books wouldn't exist. A quirky tidbit makes you chuckle. When the COBE satellite released its map of these temperature ripples in the early 1990s, one of the mission scientists, George Smoot, declared it was like seeing the face of God. Hyperbolic? Maybe. But after staring at faint blotches on a cosmic baby photo, you can forgive the dramatics. After all, it's not every day you glimpse the scaffolding of creation. Still, the interpretation of those ripples isn't without controversy. Historians still argue whether all the anomalies we see are truly cosmic or partly the fault of dust, instrument calibration, or plain statistical flukes. Are those cold spots whispers of physics we don't yet understand, or just the universe trolling us with random static? The debates continue, heating up as new data comes in, then cooling off again like cosmic leftovers reheated one too many times. You let your senses sink into this strange view. Imagine standing inside a planetarium dome, except the patterns aren't stars, but faint blotches of warmth and coolness. Each variation is subtle, just fractions of degrees. But when spread across billions of light years, they translate into entire superclusters of galaxies. It's humbling to realize that the Milky Way itself traces its lineage back to a faint hot blotch on this ancient canvas. Somewhere in that map is your cosmic birthplace, though good luck pinpointing it without a supercomputer. The glow flickers around you, and you catch yourself comparing it to a latte sprinkled with cinnamon. The swirls are uneven, some denser, some lighter, but together they make the drink interesting. If the barista handed you a perfectly uniform coffee, you'd complain it was boring. The universe, apparently, agrees. You float closer to one of the hot regions, feeling the warmth, though in reality the difference is so tiny you'd never notice it outside of sensitive instruments. Still, in this dreamlike state, you sense the pattern, the tug of gravity, the promise of galaxies yet unborn. You whisper to yourself, these ripples are destiny in disguise. The cosmic static doesn't just hum. It sings, in a way, carrying acoustic signatures of the universe's early vibrations. Later you'll hear how scientists decode them, turning light into sound waves frozen across the cosmos. But here and now, you let the variations wash over you like faint music, as though the universe is humming lullabies to itself in its cradle. For a moment, you smile at the irony. Billions of years later, humans build sensitive satellites and struggle to convince governments to fund their launch. They design detectors capable of picking up differences so small they make the Princess and the Pea story look rugged. And all of that just to prove that the early universe wasn't perfectly bland. You can almost hear the universe chuckling. I left you a treasure map in microwaves, and it took you this long to notice? Wrapped in the patchy glow, you feel at once insignificant and essential. Every galaxy, every star, every atom in your body owes its existence to those faint ripples. Imperfection, it turns out, is the secret ingredient for everything we cherish. And as you float inside this celestial baby photo, you realize that what looks like noise to some is, in fact, the grandest melody of all. You're still drifting inside that mottled canvas of faint warm and cool blotches when a new realization flickers across your mind. These ripples aren't just random. They're fingerprints, leftovers from something so bizarre and fleeting that it almost defies imagination. Inflation. Not the kind that makes your grocery bill sting, but the kind that blew the entire universe up from subatomic size to cosmic size in less than a heartbeat. The obvious truth. Without that inflationary burst, the universe would look radically different, perhaps too smooth and too flat for stars to ever form. Picture it. Fractions of a second after the Big Bang, space-time itself balloons outward at a speed faster than light, dragging every jitter of quantum uncertainty along for the ride. Those jitters, magnified beyond comprehension, get stamped into the cosmic background as ripples. You're floating among them now. Each blotch on this sky a fossil of a quantum hiccup stretched across billions of light years. It's like sneezing into a balloon, only to find that sneeze painted across the ceiling of a planetarium forever. A quirky tidbit here. Physicists sometimes compare inflation to a baker making raisin bread. As the dough rises, the raisins, galaxies to be, separate from each other. But unlike your kitchen loaf, this dough didn't just double in size. It expanded by a factor so ridiculous you'd run out of zeros writing it down. If your bread did that, you'd need a universe-sized oven mitt. Historians still argue whether inflation is the final word or just a clever patch. Some insist it explains too much too neatly, solving flatness, horizon, and monopole problems in one swoop. Others wonder if it's a placeholder for a deeper, undiscovered mechanism, perhaps something involving strings, brains, or physics that laughs at our current understanding. The debates rage like cosmic campfire stories. Everyone has their version, but no one can prove it yet. You let your senses steep in the scene. Imagine the glow around you as a vast quilt, each square stitched by inflation's frantic expansion. The cold patches are places where matter was denser, the hot ones where it was thinner, and together they hold the promise of every cosmic structure yet to come. You stretch out your hand, feeling the faint push and pull, as if gravity itself is humming beneath your fingertips. The scale is absurd. You think back to the last time you overinflated a balloon and heard it squeal with warning. Here, the universe did the same thing, except instead of popping, it set the stage for eternity. You joke to yourself. Maybe that's why the cosmos hums. Space-time never quite got over its traumatic stretch. Even the sensory experience here feels odd. The microwave glow pulses faintly, not visually, but almost musically, like standing in a cathedral where the organ pipes are tuned to frequencies you can't quite hear. You imagine the walls of space-time vibrating, and though you know it's just metaphor, the image comforts you. If the universe had a heartbeat, this is where it left its pulse. The inflationary ripples are subtle, yet they're everywhere. They've become the scaffolding for the universe's structure, written into the map of the cosmic microwave background. And scientists today pore over those patterns like archaeologists dusting off fossils, hoping to glimpse the faint traces of primordial gravity waves, distortions in space-time itself left by that initial stretching. If found, they'd be the smoking gun of inflation, the proof that the universe truly ballooned in that bizarre first instant. But for now, you simply float inside the patchwork, marveling at how chaos could leave behind such elegance. You think of how human beings, small and fragile, squabble over everyday nonsense, while this colossal blueprint hovers above their heads every night, whispering of beginnings. The thought makes you laugh softly, because really, how many civilizations get to look up at the ceiling of the universe and see quantum foam painted across it? As you let the thought sink in, the hum of inflation's fingerprints feels less like noise and more like a lullaby, steady, faint, eternal. You close your eyes, letting yourself drift, carried by patterns older than stars, older than time itself as you know it. The glow surrounding you no longer feels like a uniform quilt. It's spotted with strange quirks, patterns that don't quite fit the tidy textbook story. You drift toward a particularly chilly patch in this cosmic wallpaper, a vast cold spot stretching wider than it has any right to. It feels like a dent in the universe's baby photo, a bruise on the otherwise smooth face of creation. The obvious truth. Even the most elegant theories don't erase the oddities that stubbornly remain. You lean in, curious. The cold patch is subtle, only a few hundred millionths of a degree cooler than its neighbors. Yet when you magnify it across billions of light years, it becomes enormous. Some scientists shrug and chalk it up to statistical flukes, cosmic dice rolling funny. Others whisper bolder explanations. Maybe this cold spot is a window into another universe, a bruise from where two realities brushed against each other in inflation's wild froth. Or maybe it's just a gigantic void, a stretch of space so empty that light itself trudges through it like a hiker in sand. Historians still argue whether this anomaly is a genuine crack in our cosmological understanding or just a smudge on our lens. The debate heats you more than the radiation itself, and you can't help smirking at the imagery. A multiverse collision? Sounds like something out of a comic book crossover event. You picture alternate realities bumping shoulders like strangers in a crowded subway car, leaving behind faint bruises of static. Somewhere out there, maybe another you, is staring at another cold spot, making the same joke. You float farther, noticing not just one oddity but alignments, axes, whispers of order in a sky that ought to be random. It's unnerving, like finding all your socks in the laundry folded the exact same way when you know you didn't do it. The universe is supposed to be messy, chaotic, scattered, but here are streaks of suspicious neatness. Some call one alignment the axis of evil, though that melodramatic label makes you chuckle. Evil? Hardly. More like the cosmos winking with mischief. The sensory texture here is eerie. The glow still hums softly, but these anomalies stand out like ripples in a calm pond. You imagine reaching out to smooth them down, but they resist, persisting as stubborn scars on space-time. It's as if the universe is telling you, "Don't think you've solved me yet." And you believe it. Every new telescope that stares at the microwave sky, COBE, WMAP, Planck, confirms the anomalies are real, but whether they matter is still up for grabs. Are they hints of physics beyond the Big Bang? Or are they just statistical gremlins? You can almost hear the conference halls filled with heated debates, scientists waving their hands over graphs, coffee growing cold as they argue. A quirky tidbit brightens the mood. One scientist once joked that the cold spot might be evidence of a giant cosmic void where aliens dumped all their garbage. Another compared it to a cosmic birthmark, proof that even universes have beauty marks. The humor doesn't answer the mystery, but it makes the anomalies feel strangely personal, as if the cosmos has quirks just like people do. You linger near the cold spot, letting the faint chill seep into your bones. Though in truth, the difference is so tiny that only exquisitely tuned instruments could notice it. Still, in this dreamlike journey, the cold patch feels vast, empty, almost melancholy. You imagine drifting across it like an endless desert, the silence pressing in on all sides. Then, with a sudden flash of warmth, you glide back toward the mottled background, comforted by the reminder that most of the cosmos hums along as expected. And yet, the anomalies remain, little question marks stamped onto the universe's baby photo. They remind you that no matter how much we map, measure, and model, the cosmos keeps secrets tucked into its folds. You smile at the thought. It's good to know that even at 13.8 billion years old, the universe can still surprise us. You drift away from the cold spot's eerie silence and find yourself face to face with something astonishing. The universe's very first portraits, painted not with oils or charcoal, but with microwaves. The cosmic background radiation has been mapped in painstaking detail, and before your eyes stretch the results. Giant, colorful sky domes from satellites like COBE, WMAP, and Planck. The obvious truth. Humanity has taken the universe's faintest whispers and turned them into vivid baby photos of creation itself. You lean closer to COBE's map, launched back in 1989. At first, the picture looks like a mottled smear of red and blue, but then you realize those blotches are temperature differences only a few parts in 100,000. It's humbling, such tiny variations, yet they determine where galaxies will someday bloom. The scientists who revealed COBE's data were ecstatic, comparing it to uncovering the Holy Grail. A quirky tidbit. When NASA announced the results in 1992, Stephen Hawking himself declared it the most important discovery of the century, if not of all time. Not bad for a bunch of dots. Then you glide into MAPS territory. Launched in 2001, it sharpened the universe's baby picture into breathtaking clarity. Its map looked like a cosmic fingerprint, with patterns that not only confirmed the Big Bang model, but also measured the universe's age to within 1%. You imagine being in that control room, coffee cups scattered, scientists leaning over monitors as the data resolved into something never seen before. It's as if the cosmos had finally stopped hiding its birth certificate. But then came Planck, the European mission that in 2013 pushed the resolution even further. Compared to COBE's pixelated blotches, Planck's map was like going from an old black-and-white TV to 4K high definition. The map's subtle swirls revealed details of inflation, dark matter, and dark energy, but also reignited debates about anomalies. Historians still argue whether Planck's cold spots and alignments are profound hints of new physics or just cosmic coincidences amplified by sensitive instruments. The sensory detail of these maps is mesmerizing. Imagine floating inside one, the red regions warm, glowing like embers, the blue regions cool, soft like watercolor. The variations swirl around you, wrapping you in a cocoon of painted light. It's not like standing in front of a painting in a gallery. It's like stepping inside the brushstrokes themselves. You find yourself tracing the patches with your fingers as though they were constellations, though instead of lions or archers, these shapes tell the story of sound waves, gravity, and the birth of structure. You can't help but smirk at the absurdity of it all. Humans, perched on a tiny planet, have managed to take a snapshot of the universe at 380,000 years old, a baby picture of a cosmos now over 13 billion years mature. It's like finding an old Polaroid of a grandparent as an infant and realizing you can still see the family resemblance. You chuckle and imagine the cosmos, embarrassed, muttering, "Ugh, don't show anyone my baby photos." And yet those baby photos are anything but embarrassing. They are precise, mathematical, transformative. Each pixel carries information about density, composition, and fate. From them, scientists deduce that the universe is about 5% normal matter, 27% dark matter, and 68% dark energy. Not exactly comforting numbers when you realize most of reality is invisible and mysterious. Still, the maps prove it. The cosmos is stranger than intuition, yet coherent enough to be charted. As you let the colors wash over you, you feel a deep calm settle in. The patterns are beautiful, not in a flashy way, but in the way a heartbeat monitor or a lullaby is beautiful, steady, grounding, timeless. They remind you that the universe, chaotic as it seemed in its first seconds, grew into something structured, measurable, even predictable. And these maps, these baby photos, are proof that you are cradled inside an ordered cosmos, one that has been telling its story in light since the very beginning. You lean in closer to that cosmic baby photo, and suddenly the ripples begin to hum. Not metaphorically. You actually sense vibrations running through the light itself. The glow is singing with echoes of sound waves from the early universe. The obvious truth: before stars ever lit the night, the cosmos rang like a drum, pressure waves rippling through the hot plasma. Back in those first 380,000 years, when photons were still colliding with electrons in that thick soup, sound could actually travel. It wasn't sound like you'd hear in a forest or a concert hall, but acoustic waves of pressure bouncing through the plasma. Imagine the entire universe as a single giant instrument, vibrating with notes far deeper than anything your ears could catch. The waves compressed and rarefied the plasma, leaving behind alternating patterns, faint imprints that froze when light broke free. That's what you're seeing now, a fossil record of sound etched into the sky. The quirky tidbit: if you could somehow convert those early acoustic oscillations into audible frequencies, you'd hear the universe's first music. Scientists have actually translated them, dropping the pitch by dozens of octaves, and what comes out is a low, resonant hum. Not exactly chart-topping material, but certainly the most ancient track in existence. You imagine slapping Primordial Beats Volume 1 onto a vinyl record and selling it to hipsters who brag about listening to sounds 13 billion years old. But beneath the humor, the patterns matter deeply. These acoustic peaks, the baryon acoustic oscillations, act like frozen ripples on a pond. They determine how matter clumped, guiding the scale of galaxies and clusters. Every time you look at the spacing between galaxies, you're really seeing the echoes of sound waves long gone. Historians still argue whether the fine details of these oscillations hold untapped clues about dark energy's role in stretching space, or if we've already squeezed the best secrets from them. The debates hum on, like the faint echoes themselves. The sensory experience here is surreal. The cosmic background around you pulses softly, like a glowing speaker cone. You can almost feel the compression waves brushing against your chest, as though the universe is playing a bass line just for you. The glow seems to expand and contract rhythmically, breathing in and out with the echoes of creation. It's less like standing in silence and more like resting inside a heartbeat, steady and ancient. As you drift with these waves, you marvel at how the tiniest variations, millions of degrees hotter or cooler, translate into the vast scaffolding of reality. One ripple leads to galaxies forming here, another to great cosmic voids yawning there. Without these frozen echoes, the universe would be a bland soup. Instead, it's a cosmic symphony, each note leaving behind a structure billions of light years wide. You grin at the thought. The cosmos was noisy long before humans invented podcasts. Those ancient oscillations were the first content, a broadcast still playing in the static of the sky. And unlike most podcasts, this one hasn't gone off the air. It's been running nonstop for 13.8 billion years. Floating in this hum, you realize something comforting. You, me, everyone, all of us are part of that frozen music. The galaxies that formed, the stars that burned, the earth that spun into being, all of it danced to these first vibrations. And every time you look at the night sky, you're staring at the silent chords of a song too deep to hear, but too vast to ignore. The hum of those primordial echoes fades into a deeper rhythm, and suddenly you notice something stranger. The light itself is tracing shadows around invisible scaffolding. You realize you're not floating in emptiness, but inside a hidden architecture built of something you can't touch or see. The obvious truth: most of the matter in the universe is dark, invisible to your eyes, but stamped unmistakably into the cosmic background radiation. You drift closer, watching the faint microwave glow warp ever so slightly, pulled by the gravity of things that aren't there, at least, not in any visible sense. Hydrogen and helium atoms may fill the newborn cosmos, but their gravity alone can't explain the ripples you see. Something else is at play, something heavier, more abundant, lurking in the shadows. That something is dark matter, the unseen dancer whose steps shaped the stage. The quirky tidbit: if you took a cosmic inventory today, only about 5% of the universe is ordinary stuff. Atoms, planets, pizza, and you. Roughly 27% is dark matter, invisible scaffolding that doesn't emit or absorb light, yet quietly dictates where galaxies form. The rest, 68%, is even weirder, but that whisper of dark energy is still waiting in the wings for its entrance. For now, it's dark matter's turn in the spotlight, even if it hates the limelight. You sense it everywhere, pulling on the glow, bending the paths of ancient photons. The map of the cosmic microwave background becomes a ghostly blueprint, tracing where invisible filaments will one day weave galaxies together. It's uncanny, like seeing the outlines of a spider's web only when dew settles on it. The dew here is light, and the web is dark matter, stretching across billions of light years. Historians still argue whether dark matter is a particle we just haven't caught yet, some exotic cousin of the neutrino, or whether it's something stranger, like modifications to gravity itself. Decades of experiments have turned up hints and false alarms, but no definitive capture. It's like chasing a shadow that keeps ducking around the corner. Some researchers even joke that dark matter is trolling us, hiding just beyond the reach of every new detector. The sensory experience is eerie. You float inside a cosmic hall of mirrors, where photons bend subtly, their paths curving around invisible masses. It feels like walking through a funhouse where you can sense the presence of something massive, even though your eyes insist there's nothing there. You reach out instinctively, but your hands meet only emptiness. And yet, the weight of it presses on you, an unseen hand shaping every contour of the universe. You smirk, imagining a conversation with dark matter itself. "So what are you?" you ask. It shrugs invisibly. "Mostly I'm shy. I don't glow, I don't talk, but I keep galaxies from flying apart." "You're welcome." You can't help but laugh. It's cosmic stagehand energy, the unsung hero holding everything together while never stepping into the spotlight. And it's true. Without dark matter's invisible dance, galaxies would unravel, stars would scatter, and your very existence would be impossible. Every atom in your body clings together inside a galaxy only because dark matter said, "Stay." That thought is both unsettling and comforting. Unsettling, because reality depends on something we can't see or explain. Comforting, because the cosmos, for all its mystery, still manages to cradle you in its hidden arms. As you float in this vast scaffolding, you realize the microwave glow is more than just light. It's a message written across invisible bones. The universe's earliest photograph isn't just a baby picture. It's an X-ray, showing the skeleton of creation, etched forever in the faintest of lights. The invisible scaffolding of dark matter fades into the background, and you sense something subtler at play, an even gentler hand tugging at the cosmos, stretching not just galaxies, but the very fabric of space-time. The obvious truth: the universe isn't just expanding, it's accelerating, pushed by something we call dark energy. You watch the microwave glow ripple faintly, its patterns stretched thinner and thinner as the cosmos grows. At first, the expansion was slowing down, gravity pulling everything back toward itself like an elastic band. But somewhere a few billion years in, the expansion began to speed up, as if some hidden engine kicked in. Those photons you've been following are witnesses to it. The way their energy shifts, the way their paths stretch, all whisper of a force that defies common sense. The quirky tidbit: scientists estimate that dark energy makes up nearly 70% of the universe, yet we know less about it than we do about the Mariana Trench. Entire conferences are dedicated to debating something that could be vacuum energy, a cosmological constant Einstein once called his biggest blunder, or even a dynamic field with moods that change over cosmic time. You imagine the universe smirking. "I'm mostly made of mystery," and you're still arguing over acronyms. You let your senses absorb the strangeness. The glow around you feels stretched, like paint pulled too thin across an ever-widening canvas. If dark matter was the scaffolding, dark energy is the expansion crew, quietly adding square footage to the cosmic house every moment. It doesn't roar or blaze. Instead, it whispers, pressing outward with an invisible sigh that never stops. Historians still argue whether dark energy is constant or variable, whether it will someday weaken and let gravity regroup, or whether it will keep pushing until galaxies drift so far apart that night skies go dark. The very fate of the universe hangs on this whisper, yet for now, all we can do is measure its effects in the stretched patterns of ancient light. You picture yourself as a cosmic detective, squinting at the faintest of clues. A slightly cooler patch here, a stretched alignment there. Each subtle fingerprint suggesting that something invisible is at work. It's like trying to solve a mystery where the culprit leaves no footprints, no fingerprints, only the faint echo of a breeze in an empty room. You chuckle softly, realizing how absurd it is that humanity has named this mystery dark energy. It's like labeling your junk drawer miscellaneous and calling it a day. You imagine dark energy rolling its eyes, saying, "Really? That's the best you could come up with." But names aside, the effect is real. Without it, the universe's story would be very different. The sensory detail here is haunting. You float in a sky that seems to stretch in slow motion, the glow around you dimming slightly as distances lengthen. It's like watching the walls of a room expand while you're standing still, furniture sliding farther apart without a sound. At first, it feels exhilarating. So much space, so much room to breathe. But then a quiet unease creeps in. If this keeps going, everything will drift away, until one day even light itself becomes too faint to see. And yet, in this moment, you let the whisper soothe you. Dark energy may be a mystery, but it's a steady one, and for now it holds the cosmos in a kind of delicate balance. Galaxies still form, stars still burn, and here you are, adrift in a glow that carries the memory of it all. The universe is both expanding and remembering, stretching outward while keeping its earliest light close enough for you to hear. You drift further into the patchwork of cosmic light, and the ripples you see begin to sharpen into something more geometric. The glow is no longer just a baby photo, it's a measuring stick. The obvious truth: the cosmic background radiation provides a cosmic ruler, letting us gauge distances and scales across the universe itself. You hover near the patterns of the microwave sky, noticing evenly spaced rings in the distribution of galaxies to be. These frozen ripples, born from those primordial sound waves, are what scientists call baryon acoustic oscillations. They act like standardized marks on a ruler, cosmic tick marks stretching across billions of light years. With them, cosmologists can measure the universe's size, its rate of expansion, even its age. A quirky tidbit makes you grin. One researcher once joked that the CMB is like the universe's baby mugshot. Not only does it prove the universe exists, it also comes with measurements, height, weight, and age stamped across the photo and radiation. It's the most thorough ID card ever issued, and it doesn't even expire. As you float among these oscillations, you feel the scale of things shift in your mind. Imagine standing inside a vast cathedral where the walls keep pulling away, and yet the floor tiles beneath your feet are perfectly spaced. The photons around you carry that same rhythm, faint, frozen sound waves that measure distances with uncanny precision. You realize you could step from one ripple to another and, in doing so, measure the heartbeat of the universe. Historians still argue whether this cosmic ruler is truly as clean as we make it out to be. Dust, foreground signals, and noise from our own galaxy complicate the readings. Some skeptics wonder if we're trusting too much in a ruler that might be warped at the edges. But each new mission, COBE, WMAP, Planck, has reinforced the same pattern. No matter how you slice the data, the ripples remain, steady and undeniable. The sensory impression is oddly calming. The glow doesn't feel chaotic here. It feels orderly, rhythmic, like a grid stretched invisibly across the cosmos. You imagine reaching out and running your fingers along the ripples, like feeling the grooves of a vinyl record. Each groove corresponds to a scale, and when read correctly, the record plays the story of cosmic expansion. You laugh softly at the thought of carrying a tape measure into space, unspooling it between galaxies like a determined DIY enthusiast. No need, though. The CMB already did the job for you. It has been carrying this ruler since the moment of recombination, etched permanently into its texture. Cosmologists simply had to learn how to read it. As you linger, You notice how comforting it is that the universe, despite its mysteries, has provided a reliable tool to measure itself. You might not understand dark matter's essence or dark energy's whisper, but at least you have a ruler in hand, a way to map the vastness. It's as if the cosmos, in its generosity, said, "Here's your yardstick. Go measure me. See how far I've come." And so you float there, surrounded by ripples frozen in light, knowing that every calculation of distance, every chart of expansion, every estimate of the universe's age comes back to this invisible ruler. It hums around you, steady and precise, a quiet reassurance that even in its infancy, the cosmos left breadcrumbs for you to follow. The cosmic ruler fades gently into the background, and your attention shifts to something more delicate, the faint polarization of light itself. The photons around you don't just scatter, they twist, carrying hidden swirls like fingerprints etched into their direction of travel. The obvious truth: the polarization of the cosmic background radiation may hold the key to glimpsing gravitational waves from the universe's very first breath. You drift closer, watching as the glow isn't uniform anymore. Some of the light waves are stretched in one direction, others rotated, like the grain in polished wood. This polarization is subtle, nearly invisible unless you look with exquisite precision. Yet hidden in these faint alignments could be evidence of the universe's earliest tremors, gravitational waves rippling through spacetime itself during inflation. A quirky tidbit tickles you. Scientists label these polarization patterns E modes and B modes. E modes are neat, radial patterns. Think polite ripples spreading from a pebble. B modes, however, are curly swirls, chaotic and rare, like cosmic calyx. Spotting true B modes in the microwave background would be like catching the universe red-handed, proof that inflation not only stretched space, but made it ring with gravity's waves. Historians still argue whether any detection so far has been genuine. In 2014, the BICEP 2 telescope team announced they had found B modes, only to later admit much of the signal was likely just galactic dust. The scientific community groaned, headlines fizzled, and 1,000 cosmic jokes about dusty inflation were born. Even now, debates smolder. Are we glimpsing the faint curls of primordial gravity, or just staring at foreground smudges? The sensory experience here is almost tactile. You hold out your hand, and the polarized light brushes past like silk threads, each aligned in a faintly different direction. The swirls feel like invisible breezes tugging at your fingertips, hinting at something deeper beneath the glow. You close your eyes and imagine the whole cosmos as a woven tapestry, each photon's polarization a stitch sewn billions of years ago. You chuckle softly at the absurdity of it. Imagine explaining to someone that the fate of an entire theory, an elegant explanation for the universe's birth, hinges on whether you can distinguish primordial swirls from interstellar dust bunnies. You picture the cosmos smirking. Sure, I left you clues, but I also left you chores. Good luck vacuuming your galaxy. Still, the stakes are high. A confirmed detection of primordial B modes would be monumental, direct evidence that inflation shook the universe with gravitational waves. It would mean that space itself quivered like a trampoline, sending ripples that still echo in the faintest light. That discovery would bridge the gap between Einstein's theory of gravity and quantum physics, a union scientists have chased for decades. As you drift in the glow, you imagine the sky above Earth peppered not with stars, but with instruments, telescopes staring at the cold South Pole, satellites orbiting, detectors straining to capture faint twists in light. All of them are, in a way, chasing whispers in the dark, hoping to catch the earliest song the universe ever played. And for now, in this dreamlike drift, you let the polarization wrap around you like a gauzy curtain, delicate and intricate. The swirls remind you that even silence holds secrets, and sometimes the faintest twists in the faintest light can reveal the loudest truths about where we came from. You drift deeper into the fabric of the microwave glow, and suddenly you notice something unsettling. The patterns you thought should be random, scattered like confetti, begin to line up in suspicious ways. Entire stretches of warm and cool patches seem to tilt along a single direction, as if the universe had been brushed with a giant comb. The obvious truth: The cosmic background is supposed to be random and isotropic, but instead it shows hints of strange alignments. Scientists call one of these alignments the axis of evil, a name that makes it sound more like a Marvel villain than a physics puzzle. You chuckle softly, half expecting the glow to sprout a cape and monologue about its plans for galactic domination. In reality, it's nothing so theatrical, but the mystery is no less serious. Why should the largest patterns in the CMB seem to point along a particular axis, instead of being evenly spread? The glow ought to look the same in every direction. Yet it doesn't. The quirky tidbit here is that some researchers once joked the axis of evil might be telling us the true up and down of the universe, like cosmic GPS. Others compared it to an old TV screen with the picture tilted slightly, as if someone bumped the antenna in the 1970s and forgot to fix it. Yet no matter how you phrase it, the alignment makes people uneasy. Historians still argue whether these alignments are genuine features of the cosmos or just artifacts of our data processing. Maybe the telescopes themselves had quirks, or maybe galactic foregrounds weren't fully scrubbed out. Or perhaps, as some daring theorists suggest, the alignments hint at physics beyond the Big Bang model, multiverse collisions, cosmic topology, or even patterns imprinted by unknown forces. The debates echo endlessly, as stubborn as the alignment itself. You float closer, letting the eerie order seep into your senses. It feels different here, not the soft randomness of other regions, but a directional tug, a sense that the universe is leaning subtly in one way. The glow presses against you unevenly, like wind that keeps coming from the same direction no matter where you stand. It's uncanny, a reminder that even the universe's baby photo can make you squirm. And yet, humor helps. You imagine explaining to a friend, "So, the universe has an axis of evil." Their eyes widen. "Wait, like a death ray?" You shrug. "No, like a line where the microwaves look a little too tidy." Not exactly the stuff of space operas, but still, tidy microwaves in an otherwise messy cosmos? That's suspicious. You linger there, staring along the alignment, wondering if you're peeking into something larger. Maybe this axis is just noise amplified by human imagination, or maybe it's a clue the cosmos isn't as isotropic as we assume. The thought is dizzying. If there really is a preferred direction to the universe, then the idea that everywhere is the same collapses. Suddenly, the cosmos has a tilt, a quirk, a lopsided grin. The sensory experience deepens. The alignment glows faintly brighter than its neighbors, the pattern stretched into a long smear like paint dragged by a careless brush. You run your hand through it, expecting chaos, but instead the light hums with surprising steadiness. It's too ordered, too deliberate, and that very tidiness is what unsettles you most. And so you float there, halfway between skepticism and awe, caught in the tension that has haunted cosmologists for decades. Maybe the axis of evil is nothing more than dust, math, and chance. Or maybe, just maybe, it's the cosmos leaving a cryptic message in its earliest light, daring you to keep looking. You drift past the strange axis, leaving behind its suspicious neatness, and find yourself brushing against something even more ghostly. The glow around you feels thinner now, as though faint shadows are slipping through it. They aren't photons, not exactly. They're quieter, more elusive. The obvious truth, alongside the light of the cosmic background, the early universe also released a flood of neutrinos, ghost particles that barely interact, but still left their fingerprints in the cosmic fabric. Neutrinos. They're sometimes called ghosts of the universe, because they pass through everything, including you, without leaving much of a trace. Billions of them are streaming through your body right now, through your hands, your eyes, your coffee cup, without so much as a hello. They rarely stop to interact, which makes them maddening to study. And yet, in the first seconds after the Big Bang, they were everywhere, flooding space with nearly as much enthusiasm as photons. The quirky tidbit? Neutrinos are so antisocial that scientists build enormous underground detectors, giant tanks of ultra-pure water or heavy ice, buried under mountains, just to catch the occasional one bumping into an atom. When it happens, a faint flash of light signals victory. It's like fishing for invisible minnows in an ocean the size of the Earth. Historians still argue whether the subtle patterns in the CMB truly confirm the existence of a cosmic neutrino background. In theory, these particles froze out of the plasma earlier than photons, zipping away while the universe was barely a second old. Their existence is almost certain, supported by indirect evidence. But the debate continues about whether we've truly seen their shadow in the CMB, or if it's still inference more than observation. Some dream that future instruments may one day map these neutrino fossils directly. The sensory impression here is uncanny. You close your eyes and feel phantom breezes passing through you. Light without light, energy without glow. It's as if the air itself sighs, though nothing stirs. The neutrinos are everywhere, but they don't care that you're here. They ignore you the way raindrops ignore the space between grass blades. Their indifference is humbling, almost comical. You smirk at the thought. Imagine throwing a party and having billions of guests arrive, only to discover none of them interact, eat, or even say hi. Just ghosts wandering through your living room. That's the neutrino way. And yet, these invisible wallflowers carry secrets older than any star, secrets encoded in the faint variations of the CMB. You let yourself drift deeper, and in this dreamlike state you imagine the neutrinos as faint ripples dancing between the photons, a quieter harmony to the cosmic symphony. Where photons shout, neutrinos whisper. Where photons sketch the bright baby photo, neutrinos leave hidden notes in the margins. It makes you wonder what else might be slipping past unnoticed, still waiting for humans to invent detectors sensitive enough to catch them. And in that thought lies comfort. The universe may be mostly invisible, dark matter, dark energy, neutrinos, but even these ghosts leave traces. The CMB isn't just light. It's a palimpsest of particles and forces, each scrawling its mark on the page of creation. You float among them, listening for voices too faint to hear, content in the knowledge that even silence can be full of meaning. The neutrino whispers fade, and you suddenly catch the scent of something far less elegant: dust. Not stardust in the poetic sense, but plain, stubborn galactic dust, tiny flecks of carbon and silicate that scatter light and muddle signals. The obvious truth: the universe's faintest baby photo is easily smudged by foreground clutter, and sometimes the biggest obstacles aren't cosmic mysteries, but our own messy backyard. You drift closer to a swirl of glowing dust grains, floating lazily in the Milky Way. They look harmless, shimmering like fine ash caught in a sunbeam. But when your detectors are tuned to billion-year-old microwaves, those tiny grains scream louder than the background itself. Dust polarizes, scatters, and mimics the very signals cosmologists are desperate to isolate. What looks like the fingerprint of primordial gravity waves may just be interstellar grime on the lens. The quirky tidbit? In 2014, scientists using the BICEP 2 telescope announced they had finally found evidence of primordial B modes, twists in the polarization of the cosmic background. The world buzzed with headlines about the first glimpse of gravitational waves from inflation. But within months, it unraveled. Much of the signal came from dust in our own galaxy. One researcher later quipped, "We mistook galactic dirt for the universe's birth cry." Ouch. Historians still argue whether that episode was a cautionary tale about scientific hubris or a necessary stumble on the road to discovery. Some defend it as proof that the process works. Claims get tested, corrected, refined. Others shake their heads and point to the media frenzy as a lesson in patience. Either way, dust has become the villain of every cosmologist's nightmare. The sensory detail here makes you grin. You imagine taking a feather duster to the galaxy, sweeping away cosmic lint so you can get a clean look at the oldest light. But of course, it's not that easy. Dust grains are stubborn. They glow at microwave frequencies and mimic the very signals telescopes hunt for. It's like trying to hear a whisper in a crowded cafe while someone at the next table blasts music through tinny speakers. You laugh softly, thinking about how human error compounds the problem. Calibration mishaps, instrument quirks, even the way scientists process data can tilt results. One misplaced decimal or unaccounted for foreground, and suddenly the cosmos looks like it's hiding new physics, when in reality it's just hiding under a layer of dust. And yet, there's something oddly endearing about it. The universe, so vast and profound, is revealed not just through grand discoveries, but through stubborn housekeeping. Cosmologists hunched over maps, squinting at smudges, arguing whether a faint curl is evidence of inflation or just interstellar soot. It's cosmic detective work with a janitorial twist. As you float through the dusty haze, the glow of the Sim B looks blurred, smeared like a painting under glass streaked with fingerprints. You reach out, tempted to wipe it clean with your sleeve, but the dust just swirls, refusing to leave. It's a reminder that science is never simple, that even the clearest signals come layered with confusion. And yet, beneath the clutter, the truth persists. The ancient light is still there, humming, waiting to be disentangled from the noise. Dust may complicate the picture, but it doesn't erase it. You smile at that thought. Even in science, even in life, the important things often shine through the mess, faint but unyielding. The dust clouds recede, and you find yourself in a very different kind of chamber. This isn't the cosmos itself, but a place where humans try to recreate it. A hall of gleaming devices, the closest thing to magic that science has conjured. The obvious truth: supercomputers are our lanterns into the darkness, tools that let us simulate the early cosmos in ways the naked eye never could. You float between humming machines, though here they're dreamlike. Massive bronze gears turning, parchment scrolls unfurling with numbers, abacuses clicking like clockwork. In reality, it's racks of processors and endless data crunching, but in your drifting vision, it feels like a monastery of mathematics. Rows of monks could be imagined, their fingers flying across illuminated tables of figures, breathing life into galaxies made from numbers. The quirky tidbit: some of the first Cosmos simulators weren't digital at all. Decades ago, physicists used chalkboards and primitive calculators, filling pages with equations just to estimate how plasma behaved. Fast forward, and now we run entire universes inside machines. Cosmic weather reports spanning billions of light years. One researcher once joked that their computer played God with photon soup. And honestly, you can picture it. Code stirring like a celestial ladle in an endless simmering cauldron. Historians still argue whether these simulations are faithful to the true universe or just elaborate shadows on Plato's cave wall. Are we discovering genuine truths, or only seeing what our models are biased to show us? Some claim the uncanny accuracy. How simulations produce galaxy filaments matching telescope surveys proves the models are right. Others caution that a machine's success at mimicry doesn't mean it caught reality's essence. The debate swirls as endlessly as the simulations themselves. The sensory experience here is strange. You hover over a glowing orb of simulated cosmos. Inside it, galaxies burst like fireworks, clusters thread into filaments, and voids yawn with silence. Time accelerates. You watch billions of years collapse into seconds as stars ignite, burn, and die in the span of your blinking eyes. The machine hums with the sound of digital monks chanting in binary, though you know it's only your imagination turning code into ritual. You chuckle at the thought of explaining this scene to someone centuries ago. We built a box that makes universes. They'd probably call for a priest. And maybe they wouldn't be wrong. The awe of simulation feels almost religious. The act of conjuring reality with equations is not far from the illuminated manuscripts monks once painted, trying to capture divine order. Here, though, the manuscripts are pixel maps, lit not by candles, but by processors glowing red-hot with effort. You drift deeper into one of these simulations. The galaxies inside shimmer, looking real enough to touch, though you know they're nothing but numbers calculated from physics. Yet, they reveal things the sky itself can't. You watch photons scatter, matter cluster, filaments stretch. Then you rewind, back to the soup, the plasma, the ripples, and play it forward again. It's the ultimate cosmic bedtime story. Rewind, replay, over and over, until the patterns sink in like lullabies. But there's humility in this too. The simulations work only because we feed them laws we think we understand. Dark matter, dark energy, quantum ripples, plug them in, and the program runs. If any of those assumptions are wrong, the whole picture changes. It's like baking bread with a recipe you copied but don't fully grasp. The loaf looks right, smells right, but maybe the flavor is missing something only the original baker knew. As you stand in the glow of these artificial galaxies, you smile. There's something comforting in the effort itself, that humanity, fragile and tiny, builds machines to echo creation, not out of hubris, but out of wonder. We may not have captured the universe perfectly, but the attempt is a lullaby of its own. The humming of processors, the flickering of light on screens, the endless pursuit of understanding. And here, drifting between simulation and reality, you feel the cosmos whisper that both are valid ways of dreaming. The hum of the simulated cosmos fades, and you open your eyes to a vision of the near future. Telescopes not yet built, instruments not yet launched, but already imagined with gilded precision. The obvious truth: the cosmic background radiation is not done revealing itself, and new generations of eyes are being crafted to read its faint glow with sharper detail than ever before. You drift over parchment hills, where golden telescopes rise like cathedral spires. One resembles a great mirror of hexagonal facets, glimmering like a honeycomb against the night. Another sits at the edge of a frozen plain, South Pole skies stretched wide above, its long horn-like detectors aimed upward. In your dreamlike journey, each telescope looks more like a medieval reliquary than a modern machine, ornate, illuminated, reverent. Yet they all point toward the same goal: listening more carefully to the whispers of creation. The quirky tidbit: future projects like Lightbird, CMB, S4, and even balloon-borne observatories will stare at the sky with such sensitivity they'll detect variations in the microwave background of just a few billionths of a degree. That's like hearing the flap of a moth's wing during a thunderstorm, or in this case, catching the faint curls of polarization buried in cosmic static. And yes, some instruments really are slung under balloons, drifting through the upper atmosphere like scientific hot air lanterns. You can't help but grin at the image: monks in robes chasing after balloons to catch messages from the dawn of time. Historians still argue whether these new telescopes will finally answer the biggest questions or simply sharpen our ignorance. Will we at last confirm the primordial gravitational waves inflation promised? Will anomalies like the axis of evil vanish under clearer data, or grow sharper, forcing us to admit we don't understand? The debate plays out even before the instruments fly, with papers filling libraries about discoveries that don't yet exist. The sensory impression here is reverent. You float through an observatory's chamber where glowing parchment star maps line the walls, each marked with cosmic ripples. At the center, the telescope gleams like a golden chalice, its mirrors polished until they reflect the heavens in dizzying clarity. Outside, the cold night air wraps you in silence, the only sound a faint hum as instruments track the microwave sky. It feels like stepping into a monastery devoted not to prayer, but to photons. You smile at the absurdity of it: humans forever chasing quieter and quieter whispers. First pigeon poop static, now billion-dollar observatories in deserts and on ice fields, all because the universe murmured once and we refused to stop listening. It's endearing, almost comical, that so much ingenuity rests on detecting microwaves weaker than a glow from a light bulb. If you were the universe, you might blush at the attention. And yet the pursuit matters. Each new telescope sharpens the baby photo, giving it higher resolution, revealing details once blurred. What was once blotches becomes filaments. What was once noise becomes signal. The cosmos offers itself in layers, like a painting you see differently with each restoration. Someday, perhaps, we'll see the faintest brushstrokes of inflation's hand, or the ghostly signature of neutrinos, or something no theory predicted at all. As you drift past these golden eyes aimed at the heavens, you feel reassured. The universe may be ancient, but it hasn't stopped speaking. Every new telescope is a promise that the story will continue, that there are still secrets left in the hum of creation. And for you, floating in this soft glow, the promise itself feels like a lullaby. The golden telescopes fade behind you, and now you are alone again in the soft glow. No instruments, no debates, no dust, just you and the last photons of creation, drifting together through the great quiet. The obvious truth: the cosmic background radiation is fading, but it will never truly disappear. Those photons, released when the universe was only 380,000 years old, are still here, still traveling, still whispering their story into the vastness. The glow feels different now, gentler, cooler, stretched by billions of years of expansion. Once it blazed like a furnace at 3000 Kelvin. Now it has dimmed to just 2.7 Kelvin, a cold hum only detectors can sense. You let it wash over you anyway, like a faint warmth remembered from a fire long since extinguished. The cosmos no longer burns, it sighs. A quirky tidbit drifts into your thoughts. Someday, trillions of years from now, if anyone is still around, the microwave background will be stretched so far it becomes undetectable. Future astronomers may live in darkness, unable to see the fingerprints of the Big Bang. For them, the universe might appear eternal, with no trace of a fiery birth. In a sense, you are living in a privileged time, able to witness the afterglow while it still glimmers faintly across the sky. Historians still argue whether that fading means the universe will drift into a cold, dark eternity, or whether some new physics may yet stir its embers. Heat death? Big Rip? Or some stranger rebirth? No consensus, only possibilities. But for you, here in this glowing present, the uncertainty feels less like a problem and more like a lullaby. The sensory impression is peaceful. The photons drift past like tiny golden fireflies, their motion so slow, so delicate, you could almost catch one in your hand. They float across parchment-dark skies, their light softening into nothingness. No sharp edges, no violent bursts, just an endless, gentle cooling. You stretch out your fingers, and the glow brushes against your skin like the faintest breeze. You chuckle quietly at the thought of it all. Billions of dollars, decades of arguments, entire careers, all dedicated to studying the faintest static in the universe. And yet, what could be more poetic? This hum is our inheritance, proof that the cosmos had a beginning, that from fire came structure, and from silence came story. You can almost imagine the universe whispering, "Don't forget where you came from." You breathe deeply, though there's no air here, only the illusion of calm. The glow wraps you like a blanket, steady, eternal, timeless. These photons will continue their journey long after you're gone, long after Earth itself is gone, long after galaxies have drifted apart. They will keep telling their tale to any who still care to listen. And now, as the hum softens into near silence, you let your eyes close. The cosmos fades into stillness, the last photons flickering gently, carrying you towards sleep. And so the journey settles into silence. The fiery beginning has cooled, the debates have dimmed, the instruments are packed away, and all that remains is a soft glow, steady, faint, and endlessly patient. You no longer feel the rush of explosions or the weight of arguments. Instead, you are floating inside the quiet itself, the universe's lullaby sung in microwaves. The light here is almost imperceptible, stretched thin by time, softened into near darkness. It brushes against you like the faintest breath, a presence so delicate it feels more imagined than real. Yet you know it is real. Every corner of space is filled with it, every night sky cradled by it. The afterglow of creation has no boundaries, no edges, just an endless expanse that cradles you gently, without hurry. Your breathing slows. The pace of your thoughts eases. The cosmos itself seems to exhale, inviting you to join in its long rest. The words of scholars, the arguments over anomalies, the grandeur of telescopes, all fade now, like distant echoes fading into night. What remains is softness, simplicity, and the reassurance that you are part of something vast, ancient, and unbroken. Imagine the glow as a blanket drawn lightly across your shoulders, stitched with golden threads of starlight. Imagine the hum as the background music of sleep, quiet and unchanging. Imagine yourself drifting with the last photons, their endless journey becoming your own. The universe began in fire, but tonight it ends in calm. Let the light fade. Let the silence deepen. Let yourself rest, carried by echoes that will outlast even the stars.